the last thing that we're going to do is just really generalize what we've been talking about. And so first thing, I'm going to use this M sub SEC to mean just the slope of the secant line of f of x over some interval. And I'm going to use M sub tan to be the slope of the tangent line of f of x at t naught. And so if we read these two things down here, the average rate of change of f of x over an interval is equivalent to, okay, and this is going to be the slope of the secant line. Okay, so when we were doing average velocity, that was really just the average rate of change of the position, right? The average rate of change of the position would give us the velocity. Okay, and then the instantaneous rate of change of f of x at x naught is equivalent to the slope of the tangent line. And again, when we were talking about a position function, the instantaneous rate of change is just the instantaneous velocity. Another question that you all might have had, actually maybe even in the last part, is how do you determine the units when we're computing these average rates of change or the instantaneous rate of change? So because both the instantaneous rate of change and average rate of change come from investigating this quotient right here, they both end up having the same units, which are going to be whatever the units are for y over whatever the units are for x. Okay, and we're going to do a quick example just to get an idea of how it works. Okay. So we have a tank that holds 5,000 gallons of water and drains from the bottom of the tank in 40 minutes. And this equation right here gives us the volume of water remaining in the tank after t minutes. Okay, and so this thing only applies for t between 0 and 40. Okay, once we get past 40, it's already empty. The model's no good at that point. Okay, but if we were to think about first what the units are for our input, well, that would be time, right, in minutes. So we'd have minutes on the bottom. Okay, and then on top here, we want to know, well, what are the units of the output? So if you plug something into the volume function, what's it put out? And well, I said it. It puts out a volume, and it's putting it out in gallons. So we have gallons per minute. Okay. All right, and we have one more question here. What do you expect the sign of the instantaneous rate of change to be at any point during the time interval 0 to 40? Okay, so I'm essentially asking you, do you expect that the volume is increasing or decreasing? Okay. Well, since we're losing water, the volume is decreasing, and so we would suspect then that the instantaneous rate of change, we would expect that to be negative. All right, and that's it. Thank you for listening.